My name is Milton Friend. I'm Director of the U.S. Fish and Wildlife Service's National Wildlife Health Laboratory. Our laboratory's mission involves investigation of the causes of wildlife mortality, especially that occurring in waterfowl and other migratory birds. Lead poisoning is one of the most common causes of mortality we encounter, and is also a disease we receive many questions about. During the next few minutes, I'll respond to the major questions commonly asked of us by illustrating some of the more important aspects of this disease. Lead poisoning is not a new cause of mortality among migratory birds. The earliest reported losses in the United States were from 1894 at Lake Stevenson and Lake Surprise near Galveston, Texas. A local resident of that area indicated lead poisoning losses had been occurring at Lake Stevenson since about 1874. Since that time, lead poisoning has been reported from a wide variety of migratory bird species and from many different geographic locations. Nearly all the occurrences of migratory bird mortality from lead poisoning within the United States involves the ingestion of spent lead shot. Isolated losses due to lead contamination of waters from mine tailings and ingestion of fishermen's lead sinkers and other solid lead objects have been reported. But these are insignificant in total losses occurring from lead poisoning. Atmospheric lead has not been shown to be a cause of migratory bird mortality, nor has lead that has become incorporated into plants or adhered to plant roots and other parts. Calculations based on the amount of lead found in the air and incorporated within plant parts do not support toxic levels of lead being available to wild migratory birds. The scientific evidence for lead from shot shells being the cause of lead poisoning in migratory birds is overwhelming and without room for doubt. There are about 280 number 6 lead shot pellets in a 1 1/4 ounce, 2 3/4 inch 12 gauge shot shell. On the average, 6 shells are fired for each waterfowl bagged. This results in about 1,400 lead pellets being deposited in the environment for each bird taken. Another way to look at this is that approximately 1/2 pound of shot is deposited for each bird bagged. This amounts to waterfowl hunters contributing about 2,400 tons of lead shot into the environment each year. The availability of this shot to waterfowl has been documented by sampling the bottoms of wetlands and other areas where waterfowl are hunted. Shot densities of more than 100,000 pellets per acre have been reported in the upper few inches of bottom samples of a number of waterfowl hunting areas. The fact that waterfowl ingest this shot during feeding activities has been clearly documented by the classic work of Dr. Frank Belrose of the Illinois Natural History Survey. During the period of 1938 to 1954, Dr. Belrose examined more than 36,000 gizzards from hunter-killed waterfowl and found an overall lead shot ingestion rate of 6.6%. He also found considerable variability in ingestion rates between species and different regions of the country. However, a consistent pattern persisted despite species and regional differences. Bay diving ducks, such as redhead, canvasback, scaup, and ringneck duck, had the greatest ingestion rates, followed by dabbling ducks, such as mallard, pintail, and black duck. Ducks with more specialized feeding habits had the lowest ingestion rates. Additional studies by state conservation agencies and by the Fish and Wildlife Service on national wildlife refuges during the period of 1974 to 1982, and by our laboratory in conjunction with state conservation agencies and national wildlife refuges from 1983 to 85, have yielded similar results. More than 85,000 waterfowl gizzards were examined during the state surveys, nearly 27,000 during the National Wildlife Refuge surveys, and more than 6,300 during our collaborative surveys. The high degree of similarity in findings from these different studies serves to give credibility to the results obtained and clearly identifies that shot ingestion is primarily a result of shot deposited during the current hunting season. Ingestion rates today are essentially the same as they were 30 years ago, despite the tons of additional shot deposited during this time period. The amount of shot deposited is a function of the amount of shooting on a specific area. Ingestion of this shot by waterfowl is influenced by several variables. Weather factors that affect the amount and distribution of surface waters influence where waterfowl feed. Water depth, bottom firmness, siltation rates, and time and depth of cultivation of areas where field shooting takes place also affect the availability of shot. However, while shot that has settled 2 inches into mud covered by a foot of water may be unavailable to teal and many other species, it is available to some duck species, geese, and swans. This illustrates the importance of feeding behavior on shot ingestion. Gizzard analysis provide visible evidence of exposure to lead shot. There is no evidence for lead sinkers and other forms of lead causing significant numbers of migratory birds to die from lead poisoning in the United States. Also, while leaded gasoline is a major source of atmospheric lead, the Environmental Protection Agency reported the amount of lead used in gasoline production declined from 105,000 tons in early 1976 to about 47,000 tons in early 1980. There has been no noticeable change in the amount of lead poisoning in migratory birds during this period, despite a 55% reduction in this source of environmental lead. Lead shot that is found in gizzards represents a minimum perspective of lead shot exposure. It is the tip of the proverbial iceberg. Lead shot generally passes through the digestive tract or is dissolved and taken into the body within a 20-day period. Measurements of actual lead concentrations in liver and other body tissues are reflective of longer exposure periods of birds to lead, as illustrated by our findings from the 1983-85 collaborative lead surveys. Both the gizzard and liver from each bird sampled were analyzed. The percent of livers with elevated concentrations of lead were 2.8 times greater than the percent of gizzards with shot ingestion. Unlike gizzard analysis, which just provides physical evidence of the presence of lead shot, liver assays provide measurements of the amount of lead absorbed. Background levels of lead from sources other than lead shot have been determined from birds raised in captivity and from those dying of causes where no physical evidence of lead shot exposure was present. Most of these birds have less than 1 part per million lead in liver tissue. Therefore, we consider liver lead concentrations of 2 to 8 parts per million and above to clearly represent elevated exposure, and those above 8 parts per million on a wet weight basis to be in the range where mortality generally occurs. These concentrations of lead in liver tissue, when accompanied by appropriate pathological findings, provide an indisputable diagnosis of lead poisoning. Okay, if lead poisoning is so easily diagnosed, why don't we commonly see lead-poisoned birds in the wild? After all, avian botulism and avian cholera are highly visible. However, lead poisoning differs from these diseases in 2 ways that result in lead poisoning losses being far less visible. These are disease transmission and time between exposure and death. Avian botulism is generally transmitted through ingestion of toxic maggots. A single bird carcass can produce up to 5,000 maggots, and ingestion of as few as 2 to 3 maggots can kill a duck and perpetuate the botulism cycle. Death most often occurs within a few days after ingestion of these maggots. In large die-offs, the number of bird carcasses that occur in a short period of time quickly exceeds the capacity of scavengers and predators to consume them. As carcass buildup continues, so does the visibility of the die-off. The time between exposure and death for avian cholera can be less than half a day and often occurs within 1 to 2 days. This infectious disease is highly contagious, and die-offs with peak losses of more than 1,000 birds per day are not uncommon. Here again, the inability of predators and scavengers to consume this number of carcasses is obvious and results in a rapid buildup of carcasses and increased visibility of the die-off. There simply are not enough critters to consume all the carcasses produced as a result of most die-offs from avian botulism and avian cholera. Even so, many die-offs from these diseases are not detected or reported. In contrast, each case of lead poisoning involving lead shot ingestion is an individual event requiring an average time to death of approximately 3 weeks. During much of this period, the mobility of the affected bird is severely restricted, and the bird is easy prey for a wide variety of predators. As mobility becomes restricted, the birds seek isolation and protective cover, further reducing the visibility of sick birds and the remains of carcasses. The continual utilization of these birds as a food source by predatory and scavenger species such as alligators, bald eagles, crows, coyotes, foxes, raccoons, and domestic hogs has been well documented and prevents any appreciable buildup of carcasses and minimizes the potential for detection of losses. The Missouri Department of Conservation found 80 to 90% of the duck carcasses examined during a field study were scavenged within 5 days, and more than one-half disappeared entirely. In a Texas study, 32% of 47 fresh carcasses placed in a typical coastal marsh disappeared in less than 1 day, and by the 8th day, 89% were gone. Okay, if carcass removal of lead-poisoned birds by predators and scavengers is so efficient, why are there reports of major die-offs from lead poisoning? Fair question. These die-offs happen, but in all instances, they are the result of a combination of specific environmental conditions that infrequently occur. A major die-off of Canada geese at Grand River Marsh and Lake Puckaway in Wisconsin is an example of such an event.
You're watching one of the most tragic wildlife die-offs in the nation, ever. By the time DNR officials get the hole closed on Lake Puckaway in Wisconsin, estimates are 3 to 4, maybe 5,000 dead Canadian geese, dead because of lead poisoning. As far back as 1949, Lake Puckaway had an estimated 118,000 lead shotgun pellets per acre on the bottom of that lake.
Lack of snow cover allowed these birds to remain in the area long after the hunting season, rather than migrating to more southern locations. The cold temperatures restricted the birds to open water areas resulting from flowing water. These areas had heavy concentrations of lead shot. The prolonged use of these areas by many thousands of Canada geese resulted in several thousand of these birds dying of lead poisoning. It is important to recognize that these types of events are the exception rather than representative of lead poisoning. I cannot stress this point enough. This is a basic area of confusion regarding lead poisoning as a disease problem. This disease is typically one that results in continual losses of small numbers of waterfowl during migration and wintering periods. The collective totals from this insidious process are estimated to be 1.5 to 2 million waterfowl annually. Other major factors contributing to the lack of visibility of lead poisoning losses are the time of year when most losses occur and failure to recognize this disease. Nearly all lead poisoning die-offs reported in the literature have occurred during the late winter and early spring months. The predominance of cases diagnosed at our laboratory are from the months of January and February. In most areas of the country, hunters and others that utilize marshes and other areas frequented by waterfowl are no longer providing surveillance of these waterfowl populations. Therefore, the chance of observing lead-poisoned birds becomes greatly reduced. The reasons why this time of year is the primary season for lead poisoning losses are: first, most lead shot ingestion is shot deposited during the current hunting season. Secondly, the disturbance of hunting is over. As a result, birds can spend greater amounts of time feeding in areas where lead shot has been recently deposited. And finally, it takes a bird about 3 weeks to die after ingesting lead shot. This combination of factors results in the 30-day period immediately after the close of hunting season being the time when most lead poisoning occurs. Even when lead poisoning is occurring in an area, recognition of this disease may be confused with losses from crippling or thought to be a result of starvation or some other cause. The reasons for this are readily seen when the clinical signs and gross appearance of lead-poisoned birds are examined. Knowing where to look and what to look for are as critical in detecting lead poisoning losses as is the time of the year. A basic understanding of lead poisoning as a disease process is essential in guiding one's efforts in where to look and what to look for. Waterfowl ingest lead shot during feeding. This may be accidental, or the shot may be mistaken for food items or grit. Regardless, in an average bird, 3 to 10 days following shot ingestion, the digestive juices and grinding action of the gizzard combine to reduce much of this shot into lead salts. These lead salts reach the bloodstream and are carried to major body organs such as the heart, liver, and kidneys during the same time period. Within days 5 to 12, paralysis of the digestive tract often occurs, resulting in impactions of food items. Green staining of the vent area occurs at the same time. By days 7 to 10, depression sets in and affected birds seek isolation and seclusion, thereby reducing their visibility and increasing their vulnerability to predation. The birds lose their ability to fly between days 14 to 18 and become totally vulnerable to predators. They can be easily captured by man and his faithful companion at this time. My young lab looks like a field trial champion when he's worked on lead poisoning die-offs because of the ease with which these birds are caught. By days 14 to 20, body fat reserves have been totally used by the bird and loss of muscle tissue is dramatic, resulting in weight losses of up to 30 to 40%. Most lead-poisoned waterfowl that escape being eaten by some other animal long enough to die from the toxic effects of lead do so between days 17 to 21. Keeping this sequence of events in mind, some of the key field signs to look for regarding the occurrence of lead poisoning are waterfowl that are very lightweight and have prominent breastbones. These birds are often thought to be starvation cases, but lead poisoning may be the real problem. Another field sign is small aggregations of waterfowl that are segregated from other birds, especially late in the hunting season or after it. These birds are often thought to be hunting season cripples, but here again, our experiences have shown many of these to be lead poisoned. Reluctance to fly, and when flight is taken, inability or reluctance to fly very far is another field sign to look for. Landings by these birds are often more characteristic of crashes. Especially focus your attention on birds that remain behind when a group of waterfowl of similar species have moved out of an area. A staggering gait and other evidence of inability to stand or walk properly should also be viewed as suspicion of lead poisoning. Waterfowl found in seclusion, away from water, and in dense vegetation are often lead poisoned. Other useful field signs are abnormal wing positions. During early stages of lead intoxication, the wings are carried in a roof-shaped manner. As the disease progresses, the wings hang from the body and the wingtips droop at the wrist. Bright green-colored feces due to bile staining are also seen where lead-poisoned birds are found. Lead poisoning can also result in characteristic changes in voice of affected birds. The most useful observations suggesting a bird in your possession has died of lead poisoning include impactions of the upper portions of the digestive tract. Food items may extend all the way from the gizzard to the bill or for any portion of that area. Changes in the appearance of the gizzard are also rather characteristic. Normal gizzards have a yellow coloration and a soft, flexible appearance. Gizzards from lead-poisoned birds are generally stained green. The gizzard pads appear brittle, and there are areas of erosions within the gizzard tissue. Lead shot may or may not be present. Remember, the toxic effects of lead have been caused by lead absorbed into the system, not shot that hasn't been transformed into lead salts yet. Look also for enlarged gallbladders with thick green bile. This material is responsible for the bile-stained vents, another useful observation. Emaciation and the absence of subcutaneous fat is generally quite striking in lead-poisoned birds. The breast muscles of these birds are often severely wasted away, resulting in the keel or breastbone being very prominent in comparison to normal birds. Also, there is an absence of fat on the undersurface of the skin and within internal organs. Anemia is evident by thin, watery appearance of the blood and the pale coloration of major tissues. Heart damage may also occur. The flabby appearance and absence of essential fat tissue is strikingly evident in comparison to a normal heart. It is important to recognize that the effects of lead exposure are greater than direct mortality. Lead is not an essential trace element required to meet any biological requirements of waterfowl or other species. The body responds to the presence of lead in tissues as if it were a foreign substance, thereby resulting in sublethal effects becoming an important part of the total impact of lead exposure. Studies of these effects in waterfowl and other birds are not as advanced as those carried out for man. Therefore, there are many more questions than answers. However, studies that have been done indicate that sublethal amounts of lead can lead to abnormal behavior patterns, anemia, kidney and heart damage, and increased susceptibility to hunting. Also, field observations supported by experimental studies indicate an increased susceptibility to infectious disease. The end result of lead exposure in waterfowl is increased mortality during the year of lead exposure. Much has been said about the effects of diet regarding the toxicity of lead shot. This factor does not affect the diagnosis of lead poisoning, only its toxicity. Corn and other cereal grains are readily fed upon by waterfowl. These high-energy food items do not meet the complete dietary needs of waterfowl, and when fed upon for prolonged periods, they cause nutritional deficiencies that increase lead toxicity. High-protein diets, such as invertebrates, help to offset the toxic effects of lead, as do natural leafy green waterfowl foods. Unfortunately, agricultural crops are the primary food base for many species of waterfowl during the fall, winter, and early spring periods. Waterfowl also have an important role in the transmission of lead poisoning to bald eagles. But it is important to recognize that eagles don't get poisoned from eating lead-poisoned waterfowl. Now, that statement may seem kind of contradictory, but let's look at the process by which bald eagles become lead poisoned. First, the eagle must ingest lead shot for poisoning to occur. When eagles feed on waterfowl, they ingest the shot along with their meal. Shot present in waterfowl gizzards are also ingested when this portion of the bird is eaten. The important point is that bald eagles do not become lead poisoned from consumption of tissues with elevated concentrations of lead. Our laboratory has documented 102 cases of lead poisoning in bald eagles, 65 of which have occurred since 1980. These cases have occurred throughout the United States and are generally associated with concentrations of wintering waterfowl. The heavy utilization of waterfowl as a food base by bald eagles has been well documented, especially in areas where large concentrations of Canada geese are found during late winter. Strong evidence for the frequent ingestion of waterfowl and lead shot by bald eagles has been obtained through the examination of regurgitated remains of food items at bald eagle roost sites. However, not all shot is regurgitated, and that which remains is subjected to erosion by the extremely acid conditions found in the digestive juices of the stomach. Therefore, while an eagle doesn't have a gizzard to grind the shot down, the acidity of the stomach serves to transform lead shot into lead salts, which are then absorbed into the blood and carried to various organs and tissues throughout the body. The end result is lead poisoning when enough lead is absorbed into the body. I hope this brief presentation has provided a useful perspective for your personal evaluation of lead poisoning in migratory birds. The key points to remember about lead poisoning are: lead poisoning is not a new disease. Ingestion of spent lead shot is the primary cause of lead poisoning. Waterfowl hunting contributes about 2,400 tons of spent lead shot per year. Shot deposited during the current hunting season is the primary source of lead poisoning. Ingestion rates are highest for bay diving ducks and puddle ducks. Lead shot in gizzards doesn't provide a full picture of lead shot exposure. Measurements of lead in liver and other body tissues are also needed. While lead poisoning is easy to diagnose, it is often not recognized in the field. In addition to direct mortality, exposure to sublethal levels of lead decrease the chance of waterfowl surviving. Bald eagles get lead poisoning primarily as a result of ingesting lead shot embedded in the tissues of sick, crippled, or dead waterfowl. More than 100 bald eagles have been documented as dying of lead poisoning. If lead poisoning has been known to occur in the United States for over a century, why is it receiving so much attention now? What's the big deal? The answer lies in the strenuous efforts being made by conservation agencies and the private sector to reverse the downward trends of some of our major waterfowl populations. Waterfowl are a product of the land. More than 50% of our wetlands have already been lost, and in the United States, we are continuing to lose nearly 500,000 acres per year. These losses result in a continually decreasing habitat base upon which to produce and maintain adequate waterfowl populations to meet the needs of various user groups. The Fish and Wildlife Service, along with state and private conservation organizations, are working to produce and maintain more waterfowl on available habitat. However, these efforts have limitations. It is also important to reduce waterfowl mortality from predators and diseases. Lead poisoning can be controlled more easily than any other non-hunting cause of mortality. To accomplish this, the Fish and Wildlife Service and state wildlife agencies have worked cooperatively to identify and establish areas where only non-toxic shot should be used for waterfowl hunting. By using non-toxic shot in these areas, we have the opportunity to significantly reduce exposure of waterfowl to lead poisoning and decrease losses from this disease.